Okay, class, in this lesson, we're going to solve inequalities in one variable in 4 different real-life scenarios. So let's go ahead and get started. So here in problem number 1, we see that Angel wants to order some roses online. And the question here is, how many roses need to be purchased for florist A to be less expensive? Okay, so let's take a look here. It tells us that florist A charges $4.75 per blue rose plus a $40 delivery charge. Okay, and we're also told that florist B charges $5.15 per red rose plus a $25 delivery charge. Okay, so let's go back to the question. How many roses need to be purchased for florist A to be less expensive? Okay, so let's just think through this scenario for a second. If Angel wants to purchase one flower, okay, one rose, if he were to purchase one rose from florist A, it's going to be $4.75 plus $40, so that's going to be $44.75. Whereas if he were to purchase one rose from florist B, it'll be $5.15 per red rose, which is more expensive than the blue rose. However, with the delivery charge, that comes out to $30.15. Okay, $30.15 versus $44.75. So clearly, florist B is going to be cheaper. So the question is, at what point or how many roses does Angel need to order so that florist A is going to be cheaper or less expensive than florist B? Okay, so let's go ahead and write this down. We want to know when florist A is going to be less than, and I'm going to put this in a different color, okay, florist B. So the one in blue is going to be florist A, the one in red is going to be florist B. Well, we're also going to let X equal number of roses. Okay, let X equal the number of roses. So if we were to continue with this inequality that we have established, we would see that the cost of florist A would be $4.75 per rose. Okay, so that's going to be X. Whether it's one rose, 2 roses, 3 roses, 6 roses, whatever that number is, it's going to be multiplied by $4.75 because the cost is $4.75 per rose. Then there's also a delivery charge of $40. Okay, so the cost for florist A is going to be $4.75 X plus 40, and we want to know when it's going to be less than florist B. Well, florist B is going to be $5.15 per rose plus a $25 delivery charge. Okay, so then what we need to do is solve for X. Let's go ahead and do that. First thing we're going to do is we're going to move this $4.75 X to this side of the equation. We want to get all the X's together, okay? And to do that, we're going to need to subtract $4.75X from both sides. Okay, and when we do, what we're left with is 40 is less than 0.40x, right? $5.15 minus 4.75 is going to be 40 cents plus 25. Okay, then the next thing we're going to do is move this 25 to this side of the equation. And to do that, we have to subtract 25 from both sides. Okay. And when we do, we're going to get 15 on this side of the equation, or in this case, inequality, and that's going to be less than 0.40x. Okay? Now, to isolate x, we need to divide both sides by 0.4. And when we do, we find that x is going to be greater than 37.5. Okay? Now, let's go back to the original setup of this problem. We said that we're going to let x equal to the number of roses. Well, we've discovered here that x has to be greater than, right? So x is on the greater than side. So x is going to be greater than 37.5 roses. Well, we can't have half a rose. So then our answer is when Angel orders more than or equal to 38 roses, then florist A will be less expensive than florist B. Okay? All right, let's move on to problem number 2. In problem number 2, we see that Luke and Aisha are traveling on the same road in the same direction. Okay, so let's take a look in this picture. They are 15 miles apart and they're moving in the same direction. Okay, it tells us that Luke is driving at a rate of 50 miles per hour. So Luke is going in this direction, 50 miles per hour, and Aisha is driving at a rate of 55 miles per hour. So in this direction. Okay, so the question is, when will Aisha be ahead of Luke on the highway? Okay, and we're going to go ahead and let x represent time in hours. Okay, so let's think about this for a minute. Luke is 15 miles ahead of Aisha, right? And it tells us 15 miles ahead. Luke is going in this direction at 50 miles per hour. Aisha is moving in this direction, in the same direction at 55 miles per hour. So intuitively, we know that Aisha is going to eventually catch up. Okay, catch up to Luke because she is moving faster. The question is, how long will it take for her to do that? Okay, so let's go ahead and set up the equation. First, we're told that we're going to let x represent time in hours. Okay, so what do we want to do here? What we want to know is, when will Aisha catch up to Luke or be ahead of Luke? So Aisha, we want to know when she's going to be ahead. So, okay, Aisha's distance is going to be greater than Luke's distance plus 15 miles. Okay, we need to understand that relationship. Aisha has to catch up to Luke, okay, but in addition to catching up to Luke, she has to make up this 15-mile distance that they're apart. Okay, so therefore Aisha's distance is going to have to be greater than Luke plus 15. Okay, now when we talk about rate, okay, when we talk about rate or speed, that is equal to distance over time. Okay, how do we know that? It tells us that the speed of 50 miles per hour is miles per hour. Well, if we were to represent that mathematically, miles is distance. Okay, this is our distance. Per means divided by, and then hour is our time. Okay, right here. So miles per hour becomes our speed. Okay, since we've set up this problem as a distance problem, we need to change this equation in terms of d. Here we have r is equal to d over t. We want to change this equation as d equals some expression. Okay, so how do we do that? Well, we want to isolate d so that it's all by itself, but the problem is we have t in the denominator. So how do we get rid of t? Well, what we can do is multiply both sides by t. Okay, and when we do, our t's cancel out because t divided by t is 1. And so the net result here is distance is going to be equal to tr. Okay, tr. So now we know what the relationship is between distance, rate, and time as a function of distance, or as a function of rate and time. So in terms, what we mean is we want to set it in terms of distance. And so let's go ahead and rewrite this expression, right? So we know Aisha's distance has to be greater than Luke plus 15. Well, what is Aisha's distance? Well, Aisha's distance is going to be time times rate for Aisha, and that has to be greater than or equal to time times rate for Luke plus 15. Okay. Now in this problem it says let x represent time in hours. Okay. So instead of t, we're going to change that to x. It doesn't matter what we call it, but just for the sake of argument here, we're going to change that to x. So we're going to say r times x for Aisha is going to be greater than r times x for Luke plus 15. Okay. Now, what is Aisha's rate? Well, we're told that Aisha is driving at a rate of 55 miles per hour, so we can substitute her rate for 55. We don't know what x is. Okay, this is for Aisha. Actually, we don't need to write that anymore. 55x x is our time, and that has to be greater than or equal to Luke's rate. Well, what is Luke's rate? We're told that he's traveling or driving at 50 miles per hour. So that's going to be by 50, okay, x plus 15. So if we go ahead and solve for this, what we need to do is move this 50x to this side of the inequality. And to do that, we have to subtract 50x from both sides. And when we do, we get 5x is greater than or equal to 15. And then isolating x, we'd have to divide both sides by 5. And x is therefore greater than or equal to 3. Okay? And I apologize, that shouldn't be greater than or equal to 3. All of these inequalities should be just greater than, okay? Because that was what we established at the beginning. It has to be greater than Luke. So this answer tells us that it's going to take more than 3 hours. X is our time, and it's going to take more than 3 hours for Aisha to be ahead of Luke. Okay, so the question here is, when will Aisha be ahead of Luke on the highway? When she travels more than 3 hours. So she will catch up to Luke at exactly 3 hours. Any time after that, she will exceed Luke. Okay, so let's go ahead and move on to problem number 3. Here we have a different scenario. And so you're the office manager and you are in charge of ordering water for the office. Okay. You have two sources. Source number 1 is Natural Springs, and they charge a $15 fee and $7.50 per 5-gallon jug. Source number 2 is Dasani, and they charge a $24 fee and $6 per 5-gallon jug. So the question is, how many 5-gallon jugs will you need to buy each month for the cost of Dasani to be less than that of Natural Springs? Okay, so similar to the previous problem with the roses, if we look at just ordering one 5-gallon jug, okay, if we order one 5-gallon jug, the total cost is going to be $7.50 plus 15, or for a total of $22.50. That's for Natural Springs. For Dasani, it's going to be $6 plus a fee of $24. So that's $30. So what we're seeing here is that if you order one 5-gallon jug, Dasani is clearly going to be more expensive. So the question is, how many 5-gallon jugs will you need to purchase from Dasani for it to be cheaper than Natural Springs? Okay, so let's go ahead and set up the relationship. What we want to know is, when will Dasani be less than, right? It's going to be cheaper than that of Natural Springs. Natural Springs. And this is the total cost. Well, let's go ahead and let's let X equal the number of 5-gallon jugs. Okay, so for Dasani, we see that each 5-gallon jug is going to be $7.50. So we could say $7.50 X, and there's a charge of a $15 fee. It's probably a delivery charge. Okay, so when would that cost be less than the cost of Natural Springs? Well, Natural Springs, Dasani, I was looking at the wrong numbers here. Dasani charges a $24 fee and a $6 per 5-gallon jug. So this should be $6 and $24 fee. So let me go ahead and adjust that. All right. So this is going to be 6X and 24. And Natural Springs was what we put together, and that was $7.50 per 5-gallon jug and a $15 fee. So that's going to be $7.50 per 5-gallon jug plus a $15 fee. Okay, so now that we have the inequality set up, we can go ahead and solve for X. And to do that, we're going to move this 6X over to this side of the inequality, and we can do that by subtracting 6X from both sides. And when we do, we're left with 24 is less than 1.5x plus 15. Okay, these cancel out. Now the next step in this is to move this 15 over to this side, because we want this x to be all by itself. And we can't do that until this is moved. And we can move it by subtracting 15 from both sides. And when we do, we get 9 is less than 1.5x. Okay, and then the last step is to divide both sides by 1.5. And when we do, we see that x has to be greater than 6. Okay, so the question is, how many 5-gallon jugs will you need to buy each month for the cost of Dasani to be less than that of Natural Springs? So this tells us that it needs to be greater than 6 5-gallon jugs. So then we would need to order 7, at a minimum, 7 5-gallon jugs in order for Dasani to be cheaper. Okay, all right, now let's go on to our last problem, problem number 4. Here we have a scenario where Josh has $8 to spend on lunch, up to $8 on lunch. He wants to buy a tuna sandwich, a bottle of apple juice, and X pounds of potato salad. Okay, what are the possible pounds of potato salad he can buy? Okay, so let's go ahead and set up the equation. We know that the cost of tuna fish sandwich, so we're going to say tuna sandwich plus potato salad plus apple juice has to be less than or equal to 8. Okay, this relationship hopefully makes sense because Josh has up to $8 to spend, and the cost of all three items has to be less than or equal to 8. It cannot exceed $8. Okay, well, let's go ahead and substitute these numbers. We know that tuna fish sandwich or tuna sandwich is $4.25. So that's 4.25 plus our potato salad is $4 per pound. Okay, so we're going to say $4 times X, right? $4 per pound. So if Josh orders 1 pound, it's going to be $4. So it's going to be 4X. If Josh orders 2 pounds, it's going to be $8. All right, and then lastly, apple juice is $2.25. So plus $2.25, and that has to be less than or equal to 8. We have this inequality set up, so we can go ahead and solve for X. So let's go ahead and put these together. $4.25 plus $2.25 is $6.50. And we continue with the 4x and less than equal to 8. Now what we want to do is move this 650 over to this side of the equation, and so we're going to subtract 650 from both sides. And what we're left with is 4x is less than or equal to 1.5. Okay, and then the last step is to divide both sides by 4. And after we do that, we find that x is less than or equal to 0.375. So what this tells us is Josh can order up to 0.375 pounds of potato salad and still not exceed his $8. So that's how much he can afford to purchase. Okay, I know there were quite a few items that we covered here. Hopefully this made sense to you. If any of it was confusing, as always, please go back to the beginning of the video and listen to this again.